All right, so today we're going to be working on the law of sines. The reason you need the law of sines is when you're going to be working with triangles that don't have a 90-degree angle, and we can't use SOHCAHTOA. So the first curiosity that I want to look at is what if we look at the ratios of the three angles, and are the ratios of the three sides going to match also? By the way, let's remember to put that degree symbol on these numbers. It's going to be important when we're determining angles versus sides. And so is this ratio 50 to 60 to 70, which is 5 to 6 to 7, going to match the ratio of the sides, let's say 5 to 6 to 7 in the triangle? And the answer is no. There is, however, a ratio that is true, and that is that this ratio is going to equal to the ratio of the sine of 50 to the sine of 60 to the sine of 70. And notice all of these guys are going to be degrees, right? You never take the sine of a side length. It's always the sine of an angle. And if you're looking at the actual values you'd get there, not very nice values. You're going to get 0.766 and 0.866 and about 0.939, which actually would match that same ratio. So who cares, right? This is not going to be useful to us. However, we're going to be able to use portions of this to find missing sides. For example, if I do tell you that this side up here is 7, you'll be able to find the two missing angles by setting up ratios between the sine of the angle and the length of the side. So let's take a look at this in the next example. Here's an example that has two angles given and a side. Now, it doesn't actually matter which side is given, because even if you don't have that third angle, you could calculate it using the fact that 180 degrees is the total of the three angles in the triangle. When you're setting up the sine law, you need to have a side that is opposite to a known angle, and I could find the missing side that's opposite to a known angle. So in this case, I'm going to set this up pretending that the 40 is the A, and then that's going to put me at the sine of 40 degrees on the bottom of the fraction, which I always like to put the bigger piece on the bottom, with the 40 centimeters on the top. Being careful to remember that the 40 and the 40 here, you have to know which one's the angle, which one's the side. And then on the missing side here, I'm going to call X, and that's opposite to the 50-degree angle, which is going to be underneath. How do we solve this? We are going to cross multiply. Now, when you cross multiply, remember, it's always safe to do it multiplying up to both sides. So I'm going to multiply the 40 times the sine 55 degrees. And I'm going to do the x times the sine of 40 degrees. You can see the importance of writing the angle measures here so you don't get confused about what is a side length and what is an angle. To get the x all by itself, I need to divide by sine 40. Now remember, you can't just divide by sine. You have to divide by sine 40. This isn't sine times 40, it's the sine of 40. It's a trigonometric calculation or function. And whatever you do to one side, you have to do to the other. By the way, in your calculator, there's always going to be brackets around these things, okay? Because technically, it's an order of operations type of question. But we're usually leaving those brackets out. So the dust settles here, and we're going to have x on the right-hand side by itself. And on the left, it's going to be 40 sine 55 degrees divided by the sine of 40 degrees. Now, your calculator is going to handle this calculation well. Just be careful. I always press equals before I divide by the bottom. So it's going to be 40 times the sine of 55 and divide by, I close the bracket on the 55 to be sure, and I'm going to press equals. And then you're going to divide by the sine of 55. If you're following along here, 40 times the sine of 55 was equal to something like 48.83, all right? And you divide by sine of 40. And I get 75.96, which, yeah, that's good enough. 75.96. We tend to have one or two decimal places that we store. Actually, it's rounded up 75.97. And that's my side length here, 75.97. And I didn't talk about units. Yes, I did, centimeters. You could go on to find the missing side over here, because you know the third angle is going to be calculated as 40, 50, whatever, 85 degrees. And you can set up the sine ratios again, right, the proportions, to find that missing side. Moving on. Finding a missing angle. Now, there is an important part here that you got to watch out for. You have to know you're given two sides and an angle. One of those sides has to be opposite to the known angle. Otherwise, we have to invoke something called the law of cosines, which is in a different video. So in this particular case, I've got my 70, which is opposite to the 22. So I would say, okay, the 22 centimeters divided by the sine of 70 degrees. And on the other side, which is opposite to this missing angle here, I'll call it capital A. And remember, that's an angle, so it's the sine of capital A, and it's going to have 17 on the top. That's your setup, right? And you could have called it sine B or sine X, right? Just try to remember to put that as a capital letter, because that's what we use when we name corners, vertices, with a capital. Cross multiply. You're going to get 22 sine A. We prefer to not write sine A 22. We like to put the number in front. Whoops, let's go with the right color here. 22 sine A. And then when I multiply upwards, it's going to be 17 sine 70. Write the degrees. To get the sine A by itself, well, I'm going to divide by 22. Divide by 22. And that's going to give me the sine of A is equal to 17 sine 70 degrees divided by 22. Now, some people say, well, now I just have to divide by sine to get A by itself. That's not true, because sine of A is not an actual multiplication, it's a trigonometric ratio. The only way we undo sine is to use this sine to the -1 button on the calculator, inverse sine. And you don't actually take the inverse sine of A, you're going to take the inverse sine of that big calculation there. So let's clean this up a little bit. The sine of A is equal to 17 times the sine of 70. Get that number, 15.97 or something, divide by 22, and I get 0.726126. And I mean, I'm going to write this number down, but I'm not going to retype it into the calculator, because I'm going to keep it in the display. But what I have to do on this next step, and just for the sake of this video, I'm going to write this down. I'm taking the inverse sine of that decimal number. And as I say, I don't want to have to retype that into the calculator. So I'm just going to go in the calculator, second sine, okay, so second or inverse sine, whatever it is on your calculator, and then go, it opens the bracket, second answer, and close the bracket or just press enter. And that's going to take the inverse sine of that last calculation that we did. And so A is going to equal to 46.56, blah, 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 26082. And normally we're going to take these angles and round them to the nearest whole number. Okay, so I'm going to say that's approximately equal to 40, whoops, ugly 4 there, 47 degrees. And that's here. It's always important to remember, am I looking for a side? Am I looking for an angle when you're doing this kind of work? So hopefully this all makes sense to you. And just like in the previous question, now that I know two of the angles, I could actually find the third angle at the top here and determine what that missing side was. And who knows, you might even find out that this is, well, it wouldn't be an isosceles triangle because the angle up here is too big. But if it was isosceles, you would find that out from this kind of work. Have a great day and have some fun with trigonometry.